Can I? Yes, but I'm not doing it in class today.
How I pronounce it.
Hospitals rule. All right. So let's see what the graph of this thing looks like. So we've got, in GeoGebra, if you want to graph an e to the x, you have to type Alt-E first. If you just, with the Alt key and hit E, it'll know it's exponential. Or you can use the function notation of exp of, and then it'll know it's e to a power as well. But I want to do e to the x.
Are we in algebra or the...
Algebra is fine here. I just wanted to get a graph, is all I'm trying to do. You can use your graphing calculator for all that matters. I'm just trying to get a graph of it. And then divided by, we are in a mood, aren't we? All right, oops, squared.
I just thought you chose.
All right. So when we're doing this particular integral, we're going from 0 to 2. So I'm looking at this area where, well, I want the area underneath this function from 0 to 2. Now certainly the x bounds, the x values there, since we got vertical lines obviously, are going to go from 0 to 2. But of course we've got this curved piece up here. This function would be really hard to integrate. So you've done approximate integration techniques back in Calc 2. You've probably learned about trapezoidal rule and midpoint rule and Simpson's rule, those kind of rules for integration. This one, we're literally just going to use random numbers to help us generate the area. So the trick of this is I want this area here. I want to bound this area inside of, and in our purposes, it's going to be a rectangle that I know that this thing is underneath, or this area is contained in. So I can certainly make the base of my rectangle from 0 to 2. And just by looking at the function, I can see that it doesn't get any higher than 2. So I'm just going to bound it by this rectangle from 0 to 2 and 0 to 2. Okay? So what we're going to do is we're going to, you're okay. It's kind of funny. It was the Monty Python method. Anyway.
Society of silly blocks.
Yes, right, exactly.
I didn't want to interrupt the class.
So I'm not just.
It's just the best. Well, too late for that one.
I don't want to interrupt the class. I'll let Dr. Joe do that one.
Thank you so much.
All right. Okay. So the idea behind this is that we're going to randomly pick points in the rectangle from 0 to 2 and 0 to 2. So we'll randomly pick an x value between 0 and 2, randomly pick a y value between 0 and 2, and then we're going to check to see if the point we randomly picked is underneath the curve. And what we'll calculate then is a percentage of points that lie underneath the curve relative to the number that we picked, and then multiply by 4, because that should be the percentage of the area. Okay? So along those lines then, let me open up Excel, because we're going to do all of this in Excel. All right. So on Moodle, I posted the bunch of random numbers in Excel. You can always regenerate it. This thing's got, well, as you can tell, it was a 30 megabyte file, I think. So it's got a lot of random numbers in it. It's more than you'd probably ever want, but I wanted to make sure that we had some random numbers to play with. It's really easy to generate random numbers in Excel because there's a built-in function called rand. Right there. Okay. Now, again, you probably don't want to have all of these necessarily for everything. So if you wanted to regenerate them, that's not a big deal. But what I did here is this is just one big spreadsheet with every cell has a number between 0 and 1 in it. A random number generated between 0 and 1.
Does the function just generate 1?
Yep, that particular function is always just between 0 and 1. There is also a random between that will go between two values. But it's just as easy to scale them. We can scale them pretty easy.
Right, yeah.
Yeah, so that's what we're going to do. I just did from 0 to 1, and we'll just scale it to our purposes so that we can always just generate it off the same sheet. All right, so in this file, I'm going to open a new sheet. And one of the nice things about Excel is that I can refer back to another sheet in the same file. Are you Greta's milkshake?
I am Greta's milkshake.
All right, wonderful.
And pizza for you. Here you go.
And you were worried about interrupting class,
Stop
weren't you?
it.
There you go.
Thank
Thanks,
you.
bye.
Have a good class.
I did
Good,
it.
thanks.
Converse. Where's mine at? You don't hear it. Why don't I?
All right. So that was hilarious. Okay, so one of the nice things about Excel is that if you're in the same workbook, you can refer to other sheets in the workbook by their reference. So by the name of the sheet, I changed it to random numbers. So what I'm going to do is I'm just going to pick out 5,000 X's and 5,000 Y's out of the random number sheet, but I want to make sure that it's between 0 and 2. Right now they start between 0 and 1, so I'm just going to take whatever random number I get and I'm just going to multiply it by 2 so it scales it. And that'll give me random numbers between 0 and 2. So in A1 here, I'm going to type in equals 2 times, and then I'm going to type in random numbers, because that's the name of the sheet, whatever, except that it's not a question mark in the middle. Let me escape out so I can zoom in. Haha, I remembered without being asked. 2 times random numbers, and then an exclamation point. So what the exclamation point is telling Excel that you want to go to the sheet that's named random numbers, and then type in the cell reference. So I'll just start with A1. So all I'm doing here is just grabbing a random number out of the other sheet that we made. And the name of the sheet's not important. If you made your own sheet, you can go to another sheet and then just reference it by that. If I say sheet one more time, I'm probably going to say the wrong word. Whoever said the sheet is a good sheet slayer. Yes.
I slid a sheet, I slid a bun,
Yeah.
slid a sheet, I sit.
Yeah. Yep. I learned who said the sheet is a good sheet slayer. My father was born on a pirate ship.
This is what today is come to.
It has. All right. So all I'm going to do here is in my A1 column, I'm going to generate a list of X's. I'm going to just hit enter, and I'm going to copy that down 5,000 spots. So they had 5,000 random numbers. 5,000 is just arbitrary. You can do as many or as few as you'd like. Of course, the point of this is that you want to try to get it as close as, or as many as possible so you can try to approximate the integral appropriately. So I'm just sitting here copying down to 5,000.
Is there a faster way to do it?
Not that I know of. You may know of a faster way to do it.
If you click at the
speed
corner,
up
double click
time.
at the
If
corner.
I speed up time,
No, you gotta double click at the corner and it goes really.
say that again.
If you click at let's see, the lower right. Alright, go up there and teach tomorrow. I think there's a way. I know once Dr. Joe
All right. And then all I did was just copy that column over one spot to get the other one.
I'm not even at 3,000 yet, so we're being up in this.
Honestly, it doesn't really. I mean, the 5,000 is arbitrary. If you don't want to copy all the way down, just make note of where you stop.
I'm almost at 4,000. Oh, you got there.
I'm over at 200.
It's going really slow. I'm literally like type another number.
Like, so, I like type like a 1 or something over here, and then all my numbers change.
Yeah.
Why?
Because it recalculates the random number every time you do a new calculation.
Even if it's on the
It does.
Gonna have the same as you.
Yeah, you would not have the same as me. No one here should have the same answer.
I have the exact.
If you did, you cheated.
Or we're just really
Is
smart.
it? I don't know, I didn't actually try it.
You
Oh,
all the way back up to the top.
what was it?
Apparently, if you go to like the little, I don't know, something over on this side, there's a button that says series, and if you open that up, you can say, like, go down by 1 and stop at 5,000.
Oh,
Wait, what?
What?
I googled it.
Wait, there's an autofill option saying you can't.
oh, you need to go to Google and open the file. That has very good.
Oh, it just says copy cell. I have it.
Under
That's
Okay.
that little-
Oh, so you just want to make a new sheet in this file? Together, guys, together. Yeah.
Is there an easy way to copy them?
I just already had it highlighted, so I just grabbed it and copied it over. What is it you do, Haley? You don't know?
Go to under the summation. There's a little arrow pointing down.
All right.
Oh wait, I'm back and you don't.
That almost sounded derogatory. I'm sure there is a way. I just don't. I was too lazy to look it up, honestly. All right, do what now?
Okay, so on mine, on the top right in the toolbar, I have the sum button. And below it, there's a fill.
Oh my god, it's
Home
done!
tab sum.
Amazing!
The home tab has a
Hit
sum.
home.
Sum.
Under the sum.
Home.
Under the sigma, there's a.
Here?
Yeah, under the next one. Down.
Oh, under the sum. I'm sorry.
The arrow, yeah.
Oh.
Is series. And then over.
It says click on the series. And then
Autofill, the fourth one. Here, series and columns. Oh, it doesn't tell me how to stop it though.
no, it says you use the linear.
And make a step value of 0?
1.
Why would I make a step value of 1?
I don't know. This is
Oh,
like
I fill every
one
cell.
That didn't
value.
work, Haley.
And then a stop value.
Yeah, it's just going to add 1 to all of them. That was.
So try it with a step value of 0. I was just reading what Google told me.
That was what I was going to try was a. But I think it'll just. Home. Series. Yeah, so that's just going to do.
Nope, try. Oh wait, trying might work. No.
Yeah, I don't think that worked. Anyway.
You have to copy it over to the phone.
No, I just highlighted it and just, yeah. All right, anyway. So I'm going to treat the first values in the column, sorry, the values in column A as the x's, the column of the value B as the y's. So what I want to check is the random point that we pick, the x value comma y value, is the y value underneath the curve? Does the y value fit underneath the curve? So what we're going to do here is say if when I take the function value, so in Excel, the formula for the function for e to the x is exp. So I'm going to do e to the x, so e to the a1 divided by 1 plus a1, maybe, squared, if that is greater than the y value. So what we're saying here is plugging the random x value into the function and evaluating the function, is that point on the curve above the random y value we picked? That's what that's saying. Does that make sense? We're picking a random x value, plugging it into the function. Is the random y value below it? If it is, we want to count it. If it's not, we don't. Okay? So that's why I said, is the function above the random y value? If it is, we'll assign it a value of 1. If it's not, we'll assign it a value of 0.
Can you go back to what's in
B, what's in B is the same thing as what's in A. I just copied the column over it.
Can you explain why we're doing greater than B1 again?
So our function looked something like this, right? Roughly. Okay. So we pick some random xy value. This is the random one. If I take the random x and plug it in the curve, it's going to be up here on the curve. This is the random x and then f of x. The f of x isn't random. So if this value for f of x is above the value for y that we generated randomly, then that point is below the curve and we want to count it. As the one, yeah. Because I want to count, because again, we're trying to count what percentage of points are below the curve. We're basically thinking about taking a bunch of dots and filling them in. I think I'm going to draw a picture, or have Excel create a picture here in a minute that hopefully will help show you what I mean by this. All right, so this one I really do need to copy all the way down again. If somebody finds a faster way to do it, let me know. What's that?
You just have to click on the right side.
Click on the right side of what? I don't know what you mean.
Just go to the top. Just go to the top.
Okay, go by the top.
So once you have that, go to the corner of the bottom corner.
The bottom
Of
corner.
that box. And
Okay.
then you could double click on that, and it just goes all the way down.
Forever or to the what? To the bottom?
To the point you have the.
Oh, okay. Well, thanks. Well, that works.
I'm pretty sure he tried to say that a minute ago.
Yeah, I
but
think I
then-
heard that.
Yeah.
No, but it you can't do that for the first column.
But I can't do that for the first column, though, right?
But it just goes to the end of the page, and then you can just do it again and again and again.
Oh, I see.
Yeah.
I got what you mean. Okay. Fair enough. Thank you. All right.
What did I just do?
I don't know. What did you do? All right.
Should I get any zeros at all? Because I'm getting a one.
What's A1?
You should.
Keep scrolling.
It's
It's all only one? You probably typed something in there.
times
I'm gonna redo it.
random numbers. Exclamation point.
Usually on my data.
Oh.
I don't know how. And then A1, yeah. How did he say that he did that? You just
Double click the corner.
If we write
It didn't work the
if
first
we
time
write
I
a
did it.
function for this in Python.
Yeah.
Just because I did that. I just wanted to see it.
Oh yeah. If you can do this in Python, this is much faster.
Yeah.
Or any programming language. This is probably faster.
100%. Some people
What?
that it's faster.
100% is faster?
What do you think?
Yeah, if you want to write a Python code and do it, that's fine. I don't care. All right. Again, we're trying to figure out the percentage of points that lie under the curve, the percentage of random points that lie under the curve. So I want to do a count if, and do A1 to A5000, and if it's equal to 1. Not A1, sorry. C1. And again, notice when you recalculate, it'll change. What we're doing is what's referred to as Monte Carlo simulation. So if I run this over and over and over and over and over and over and over again, I should get different numbers because it's random. I mean, that's what makes sense.
Go back to the formula.
I'm just, all I'm doing is count this one?
Yeah.
Okay, all I'm doing is counting the number of times 1 comes up. So it's the countif function. And instead of going down and highlighting the array, I just actually typed in the number so I didn't have to try to get all the way to the bottom. Yeah?
So how are you recalculating
I just was, all I did was just move over to a blank cell and just kept hitting the delete key.
Delete?
Yeah. All you have to do is just change a cell. The delete's trying to change a cell, is trying to delete the contents. As soon as you change any cell anywhere in the worksheet, it recalculates the random numbers. It literally regenerates the function every time you change a cell. Doesn't matter what cell you change, the random function automatically re-randomizes. So the delete key will try to delete whatever's in the cell. Even if it's empty, it'll delete whatever's in the cell. So it'll just recalculate every single time. So you can see that I can generate a whole bunch of trials at once. All right. So again, I want a percentage of points. So I want to take D1. We have 5,000 points. That should be the percentage of the rectangle we started with, right? We picked all these points from 0 to 2 for the x's and the 0 to 2 for the y's. So that D1 over 5,000 should be the percentage of the rectangle the area takes up. Okay? Well, I need to multiply that by the total area then. So the total area of the rectangle is 4. So I need to take this multiplied by 4. So we get 1.69 or 1.71 or 1.66 or 1.69 or 1.72. This is why I said none of you should have the same answers.
Wait, what was in D2? I don't even get that.
Yes, mine's 2.68.
Oh, I didn't have it.
Yeah, mine's 2.7.
So the so Dr. Joe,
I wonder why yours is so much higher. This doesn't make
Well, I have a lot less data
Well,
points,
yeah.
and mine took forever to drag down.
I have 3,362.
We have the same.
You have 2,168.
Yeah, I have the same as y'all. I still have 5,000 data points.
And how many data points? 5,000?
Yeah.
Wow, thank you.
Very bottom.
Oh, it's because mine didn't go all the way down. Aha! So whatever Nawaj told me didn't work.
What's the answer? I'm trying to change this stuff.
It works for me.
Press Control down.
I'm just,
Am I good?
there we go. Okay, now I'm at the bottom. Apparently I had to do it twice. It didn't go all the way down to the bottom the first try.
That's because you didn't erase the.
You can do Control up to get to the top of the page.
Or home. Or home.
Yeah.
Yeah. All right, there we go. How's that? That better?
Yeah.
See? All sorts of ones. So if you wanted to run multiple simulations, there's a couple of ways you could do multiple simulations. You could take, instead of, we just had columns A and B and C, I could recopy those. And then each of the, so I could do A, B, and C. So A is counting in X's, or A is giving you X's, B is giving you Y's, C is giving you a count. I could do D, E, F and do it, or actually I could do E, F, G, do it again. Count it up. I could do, and then I could have several simulations, and you could do an average of the different simulations if you wanted to try to average the different trials. So if you wanted to get a whole bunch of them, you could do it. What I mean is, to show you what I mean here, if I just take the columns that I have here and copy, and then I could paste them, there's another, notice now I have two different simulations. That was why I gave you a sheet just filled with random numbers. You didn't smack my elbow. But if you wanted to do a whole bunch of simulations, you could do, just keep going here and then do another one and do another one and do another one. That was why I gave you so many columns of data.
Bless you.
So I just took the first first four columns and then just kept copying them over. And again, what you might want to do this is because now you've got a whole bunch of different simulations for what the area might be. You could average those and maybe give you an average value to get an approximation for the integral, that kind of thing.
So if we increase the number of points, does that mean, do we necessarily get better and better values?
You should. You should get better values. I mean, it doesn't guarantee it because it's all random, but you should get better values.
I mean, I just did for 100,000 points, I'm still at 2.65.
Okay.
3.2.
So what is the 2.6 whatever represent?
The area. The value of that integral.
Exactly?
No, well, not. It's an approximation. Because we just did it with random. Here's what we're actually. I mean, if I show you the picture, let me see if I can do this here.
Is this going to be on our quiz?
Yes.
Okay. Oh, it is?
Yes.
Oh, so we need to know.
All right, so let me show you what I mean by this. All I'm doing over here is
What's the
it's e to a power. Exp is e to a power.
Okay.
Y1 divided by 1 plus. You don't have to do this. You don't have to do the second part. I'm just showing you what's going on. Is greater than y. Oops, not greater than y. Greater than v1. Then v1, otherwise 0. All right. Oops. Oh, that's right. Insert, hopefully that worked. A scatter plot. That's not a scatter plot. Try this again. There you go.
Whoa.
So those are the random points that we picked that were under the curve. And notice the top look has the shape like we did, right? So this just plotted the 5,000 of the 5,000 points that we had. In this case, I just based it on the U and V columns. So of the 5,000 points, it plotted 3,352 of them that were below the curve. And so you can kind of see how it's filling in the area with points, essentially.
Why did we do times 4 in itself?
Because the area of the rectangle we chose to show those 4. Because the division is a percentage of the points that land under the curve. So that's a percentage of the area. So we multiply that by 4 to get the area.
Okay, so if it was from 0 to 1, then we.
Just wouldn't have to multiply by that anyway.
Okay, but if it was 0 to 4, then we divide by 16. Or
Multiply by 16, yeah. Oh, well, your x was 0 to 4. Then you also have to pick your y for how tall you need to be.
Okay.
So that matters too.
Okay.
So the range of values that in our sheet you gave us, you set it up to be between
0 and 1 all the time, yeah.
So that's why we multiply by 2.
2 to be between 0 and 2, yep. That's exactly right, yep. That's kind of cool though, right? You see the points? This is one of the reasons why I wanted to do this, is because I thought this was cool.
Do we know what the actual integral is?
Well, we can approximate it. That's what GeoGebra is for, right? So if I just say integrate number 1 from 0 to 2. That was interesting. No. Didn't like it. How about I integrate?
Do you have to be in the list?
Let's just do it this way. F of x from 0 to 2. There we go.
With the 2, we took it times 2. Is that
Because with the random numbers, yeah, because it would make it go from 0 to 2, right?
So if it was like 0 to 4,
Yeah. Yep. Let's do another one. This was fun, right?
What if it was like 1 to 2? Honestly, yeah.
That's what I was going to show you.
Okay.
So let's see here. Let's do, say we had integral from 4 to 6. Of natural log of x cubed plus 2 dx. I'm pulling these problems out of the Calc 2 book, where your calculus book is from Calc 2. Just to see. Because that was the approximate integration. It put out of section 7.7 on your Calc book. All right, so let's go back over to Excel here. I'm just going to open up a new sheet in the same one so I can still refer to the random numbers. All right, so let's say here I want to equals, I need to start at 4 and end at 6. So what we're going to type in here is 4 plus 2 times the random numbers. Oops, I didn't zoom in again, sorry. Oh my goodness. You know, as many problems as we've had, I still had a good time with you guys.
So what you're saying is you're going to miss us.
I always miss you guys.
See me next semester.
I will see you next semester. Some of you I will see, but I will miss it. I mean, it's been some struggles, obviously, but I've had a good time. I always have a good time. Yeah, I bought you pizza, so, you know.
So you must like us.
We're doing it for theory of interest too.
Pizza?
Keeping tallies.
You never know. I'm also teaching probability. I switched with Dr. Lee. So anybody's taking probability off me too. Yeah.
Alright, I gotta take a class on my schedule.
Didn't like your formula.
Wait.
Dr. Joe classes.
What's that?
Why do you put an A1?
Theory of interest is
Probability, yeah.
No, I got to figure out what class I'm not taking next semester. No, I can't do.
Yeah, no, especially
You
back to
might want to
back.
drop 2 documents.
This would be easy.
I can't take 20 credits in 2 doctorate. Yeah.
Okay,
What's your other class?
Freedom of interest.
Yeah, that's right.
do that one.
You won't get
I
the
have to
same
take
numbers.
probability.
It's based on.
Why are you?
They won't be the same numbers.
I mean, but they're,
You are?
Yeah.
Oh, yeah, because it has to be before 3
I
4.
switched.
We've generated
decided
a number now
to
to
do it this
6.
semester.
The only thing is,
how do we know that though? Can you explain that?
You're an
again?
interest.
so we start the two. So the numbers that are in
So
the random number sheet are between 0 and 1.
Okay.
The 2 times that makes it between 0 and 2. And then we add 4. We just shifted it 4 units to the left or to the right.
Okay.
Yeah.
Makes sense.
It got like 4,000, so went to 8,000.
All right. So if I double click this, no, nothing's happening when I double click it.
Well,
What to do with the first time, right?
maybe.
I might push computer science off.
I think it's much.
And theory of interest is not bad
I just don't want to take 20 credits next semester now.
because I'm teaching the other class.
Because I feel like probability is going to be like 2 classes worth. I already dropped it once. I don't think I can get away with it.
Holy cow! All right. There we go. Whoops! I didn't necessarily want to do that for the Y's. Sorry. Let me delete this column.
Oh, you don't want to do that?
No, not for the Y's. Oh no, I do. No, I don't know. I don't want to do that necessarily for the Y's because remember we're trying to get the area under the curve. So let me turn that one off. Turn that one off. Turn that one off.
4 plus 2.
All right. So let's just graph natural log of x cubed plus 2. Ooh, hey.
4 plus.
X cubed is 2. All right, so we're going from 4 to 6. Here is the integral here, right? All right, so we want area under the curve. So our x's definitely need to go from 4 to 6. Our y's should start at 0, right? If we're going to count area, our y's better start at 0. How high do you think we should make our y's to make sure we get the function underneath it? 6? Okay. So instead of going, I don't want to just copy them over. For the second column, what I want is, I just want 6 times the random numbers.
We didn't do that last time.
Well, how come we didn't do it last time? Because both our x's and our y's went from 0 to 2, so we could just copy it over. I didn't have to change it because I had the same length of interval for my x's as I did for my y's. In this case, my length of my intervals is for x's is 2, but the length of my interval for y's is 6, so I have to change it. Plus, I don't want to start it at 4. I want to start it at 6. I mean, you could be clever and try to start it at a different number and then just make sure you add in the area of the rectangle below it. That actually could probably get you better approximations. What I mean by that is, if I go back over here, notice that the function from 4 to 6, the function is also above 4, right? So I could do my y's also from 4 to 6, and then just make sure when I do the total area, I add in 8, because that's what this area would be here.
Wouldn't that be more accurate?
It probably would be more accurate, yeah, because I'm not doing the random along here.
Is that what you want us to do on the test? Or?
No, I'm just doing it this way. I'm just telling you it could be more accurate. I just want you to get a feel for how to do it. I'm not going to be asking you to do anything different on the test than what we're doing right now.
Could we, in the test, could we use our Python script?
Yeah, if you've got a Python script written, yes, you can use that.
Literally 10 minutes. Because
It literally shouldn't take very long, though. If I can do it in Excel this quickly, it should not be a very long Python script.
plus you could increase the number of pairs.
You could also write a Visual Basic script and import it into Excel and then have Excel do it that way. There's lots of different options. You could write it in Java, you could write it in C. You could probably do it in GeoGebra because there's a random command in GeoGebra too. Everybody's like, screw that! All right.
So for column A, you put A1 if it's not B, so A1 at the end of each one.
Yes. Because I'm using the first column in my random numbers file as my x's, and my second column is my y's.
Did we do that on the question?
I just literally copied the first column over to the second, so it just automatically changed it.
Okay.
And the reason I did that last time was because both of them were going from 0 to 2, so it was the same formula. Yeah.
That's how you do it.
How you do what?
I just figured out how to have it fill all the way down. So try to do that by 5 minutes.
All right. Oops, not count if yet. I want to do the if command. If I want natural log of a1 cubed plus 2, if that is greater than b1. So the random y coordinate we picked is below the curve. We'll make it a 1, otherwise we'll make it a 0. And then here we'll count again. Sorry. Count how many of them are 1. So this is the same command. The only thing that's going to change from file to file or from sheet to sheet is when how you're generating your random number to be in your intervals for your x's and your y's, and then your function. I mean, otherwise it's exactly set up the same. So again, I picked 5,000 points, so I'm going to do D1 divided by 5,000. And then we need to multiply by the total area. X's were 4 to 6, so that's linked 2. Y's were 0 to 6, that's linked 6. 2 times 6 is 12. So I'll multiply by 12. And so we get about 9.6. And again, if I play with this, I can see different values coming up. But you can see there's a little bit more bounce to these. There was a 9.73. There's one that's 9.55. So like Grace mentioned earlier, it's probably not as accurate because, again, I'm picking a bunch of random points that I know are going to be below the curve because it's in that rectangle. So if we picked our y values between 4 and 6 as well, it's probably more accurate. And then just add an 8. Is anybody else getting 9 something?
Yeah.
Okay. Good, great.
Up in cell D1, you have like a C1 dot C5000.
Yep.
Is using a semicolon the same thing?
Yes. When I first learned spreadsheets, it was dot dot. That's why it still works. Semicolon's the same thing. It's just I don't have to hit the shift key. I can just hit dot dot real quick and get one. But that was how it was had it in when I first learned.
I was just wondering.
And you gotta remember, I learned spreadsheets like 25 years ago, so.
Did it all the way down to 5,000?
25? Oh no, it's been more than that.
I just think it's short and Python's good.
Well, I have to.
It's more like 30.
So it doesn't.
Yeah, it was like 30 years ago.
You know what?
And your picture for on the
That's
board,
good.
your random y value
Mm-hmm.
below the curve, is that just the 1?
That should be one.
Okay.
Here's Gilbert's desk. So everyone should know.
We have
D1, and then 5,000 is just the number of points. And then I multiplied it by 12 because 12 is the total area. Because remember our x's went from 4 to 6,
You do the same thing.
so that linked 2. And then there's y went from 0 to 6, that's linked 6. So the area went from 12.
I don't know, he didn't do
swallow
it.
it.
Is it greater than or equal to or just greater than?
It doesn't matter because it's random. The probability that you actually hit the value is 0. So you can, you can do greater than or equal to. It'll be exactly the same. I mean, it should be exactly the same thing.
I did 10 million. That's a million. Million.
Yeah.
9.652138.
Okay, well let's see what we get.
Let's see.
Let's see.
Oh, of course.
integral of g of x
Surprisingly, it's the same thing.
of 4 and 6. And you got, what did you say?
I got 9.65211328.
That's what I got.
9.65.
21.
Okay, so let me change the settings here. There, that was, this is 9.500.
What did you do in the rush? Let me run it again. Well, it takes a while.
Oh, you did 10,000 random points? Or did
10
you
million.
do 10 million, just random points, but one simulation?
Yeah.
Why don't you do 1,000,000 points and run 10 simulations on average?
Yeah, I'll do that.
Try that and see what happens. Because you're just doing one
Yeah.
shot at it. Do several shots on average and see what happens.
Yep.
So again, we could plot those points. I'll do that real quick. I think it's kind of cool to see the plotting of the points. So equals. Let's just move A1 over, and this one will say if E1 is natural log of E1 cubed plus 2 is greater than B1, then put B1, otherwise put a 0. And then insert a scatter plot. There you go again. So it fills it in. It's not as cool as the curve because it's just got that one little bend in it.
That's still pretty cool.
Still pretty cool.
It's pretty neat.
Yeah. That's okay? You can do these for other integrals as well. You can do them for double integrals. You can do them for triple integrals. Want to see a double integral? Sure?
We
All
don't
right.
need to know it.
Huh?
We don't need to know it.
Yeah, I just want you to be able to do what I just did.
Okay, all right.
How
You
many-
have your
how
fun.
many values?
What's that?
How many values?
Well, do 1,000,000 and do it 10 times. If you
Okay, 10 times.
Sure, why not? Or do 500,000, do it 20 times. I don't know. You said you did 10 million trials. I was just going to compare it. I was just getting to say get up to 10 million trials again, just splitting them up. All right, so this I think is actually an example that's in your book, but let's say we wanted to find the volume of a broken piece of chalk. Find the volume under, let's say we had z equals the square root of 2 minus x squared minus y squared, and above z equals the square root of x squared plus y squared. You should be able to tell me what the first shape is. What kind of surface is the first one? Square both sides, move the x and y over to the left. Well, it's 3 dimensions.
Sphere.
Sphere, yeah. Oh, the top one's a sphere. What's the bottom one? If I slice this horizontally, perpendicular to the z-axis, I get circles all the way up, and they're going to be expanding. It's close to a parabola. It's not round at the bottom, though. It's going to be a sharp corner, so it'll be a cone. Yeah. It's like it's kind of like a parabola. If I would have not had that square root on there, it'd be parabolic. You're exactly right. But the square root on there makes it actually come to a point at the bottom. So you actually get a cone. So this shape, 3-dimensional shape, looks like an ice cream cone. Okay. So if I check this, let's see. The absolute highest this gets, well, this is a sphere of radius square root of 2. So my z values here, the lowest z value we have is 2, or excuse me, 0. The highest z value we have is 2. So our z's will go between 0 and 2. Basically, I'm trying to trap this thing in a box. So that I know the volume of the box. Just like we did trap the area with a rectangle, I'm trying to trap this solid in a box. Does that make sense? All right. This circle, it's not too hard to see that this circle above the xy plane is the circle x squared plus y squared equals 1. If you set those two things equal to each other, it'll simplify to x squared plus y squared equals 1. If I set them equal, square both sides, and move the x's over, you'll get 2x squared plus 2y squared equals 2. So you get x squared plus y squared equals 1. Now you could randomly select points in that circle, but it's just as easy, since I said I want to try to use a box anyway. If you're in the circle of radius 1, you're certainly inside of the square with each side of 2, right? Because your x's go between -1 and 1, your y's go between -1 and 1. So your x goes between, are you still waiting, Julia?
Yeah. I think I typed in 10 million.
What's that?
I typed in 10 million instead of 1 million.
Oh,
It's
so
just gonna take a second.
it's going to take a little bit. Everybody see why that's the case? That the x's and the y's go between -1 and 1? Right? I'm going to have to make sure that I have a little bit more of a condition on these two. Because I also need to make sure I'm inside this solid. I don't want to just base it on my z if my x's and my y's land outside the solid too. So I'll have two conditions that'll have to be met. Okay. So when we do this one, I need 3 coordinates. So let's do, I want my x's to be between -1 and 1. So I'll say -1 plus random numbers of, I need 2 times that, sorry, A1. I put it 2 times out in front, and I know I didn't zoom in. So what did you do? Time 2 times. So again, I put the -1 there because that's where we need to start, and I did 2 times because I need to stretch it to an interval of length 2. Just like the previous one. All right, so I have to copy this one down first. There's got to be a faster way to do it. Probably the faster way to do it is just to use the sheet that I already had filled in. But that's okay. It's more fun to try to get it back to 5,000 again while you can't really see. There we go. 5,000. My y's need to go by the same interval, so all I need to do is just copy this over a cell. So that'll get my x's and my y's. My z's, however, need to go between 0 and 2, so I just need to do 2 times random numbers of C1, and then fill it in. So instead of just randomly selecting x and randomly selecting y, instead of just randomly selecting x and randomly selecting y, all I did was I just added a column, and now I'm randomly selecting a z too. Okay. All right, so now our if command is the following. The first thing I need to do for our if command is check to make sure I'm in the unit circle. I need to make sure that x squared plus y squared is less than or equal to 1. I know, I said unit circle. I know. So if a1 squared plus b1 squared is greater than 1, then I don't want it. So I might as well just put a 0. Right? If a1 squared plus b1 squared is bigger than 1, I'm outside the unit circle. So I don't want the point. So I'm not even going to count it. I'm just going to make it 0 automatically. Okay? If I need a couple other conditions to be met. If I'm in the unit circle, I need to make sure I'm in between these two surfaces, right? So I need the z value to be below the sphere and above the cone, right? I have to make sure the z value we select is below the sphere and above the cone. So we need if, see, is it and? Okay. think I can just put that in there. Let me see if this works. If our C1 is less than, what do we need to be less than? I need to be under the square root, oh, sorry. I need to be under, so I need to try it this way, sorry. If I do the square root of 2 minus A1 squared minus B1 squared, if that's bigger than the C1, actually, why don't I do it this way? I'm just going to do nested ifs. I'm going to make it less than the C1. If I plug in the A1 and the B1, and the value that I get out for the surface is below the random value, then I want to throw that one out too, right? So I'll say comma 0. Otherwise, the last if is, I'll go the other way, square root of A1 squared plus B1 squared is greater than C1. I forgot to close off my parenthesis, sorry. All right, so if I plug in A1 and B1 into my cone and it's above the Z value, I don't want that one either, right? So I'll put comma 0 and then comma 1. So I finally got to the end here, and I need to close a couple of brackets. This one was a little bit more complicated because I had to check a bunch of different conditions, right? I need to make sure my X's and my Y's are in the unit circle, and I need to make sure that we're in between the two surfaces. So it was a little bit more complicated. And I did it with a nested if statement. If I miss one of the conditions, I just want to throw it out. If I finally get all the way into the last one and I make it, then I make it a 1. So that's what that did. All right, so let's fill that in. Cool. And let's count. Now the rest of it's just like we did before. Count if D1 to D5000 is equal to 1. And we'll do the percentage. So I want to do D1 divided by 5,000. And now I need to multiply by the volume of where I picked out the points, right? Well, we picked out the points out of the 2 by 2 by 2, right? We picked it out of a box that had length 2 all the way around, right? So I need to multiply this by 8. Whoa, that was weird. Oh, it's because I put D1 instead of E1, sorry. I was thinking of the previous formulas. There we go. So we get a volume that's about 1.7. A little bit bigger than 1.7 now. Oh, there's a whole bunch of them. So in this case, remember when you do volumes between two surfaces, that's a double integral. So you can do the same for double integrals. You can do triple integrals. And you can do sextuple integrals if you wanted to. That'd be weird. But you can. If you do multivariate statistics, you have to do lots of multiple integration. And that happens if you do random samples that are large. I mean, if you have continuous random variables, it'll do the same thing. So we can check what the value here is. If I remember what the value is, I did it in my calc class the other day. I don't remember what it was off the top of my head, though. I just did this the other day in calculus. Because it's one that you can convert to polar pretty quickly. This would be integral from 0 to 2 pi, integral from 0 to 1, because I'm just over that region. And then we would have square root of 2 minus r squared minus r dr times r dr d theta. So if I wanted to actually figure out what the volume is, I have a feeling I'm talking to myself at this point. If I want to integrate to integral of the integral, now let's just do this first. Oh, that's right, I'm not in a CAS mode. Let me flip. All right, let's do the integral of the integral
Till 6.
of, I'll do the square root of, oops, I need parentheses here. Square root of 2 minus, let's do x squared minus, oops, too far, minus x times x from 0 to 1, and then from 0 to 2 pi. That was weird. Why didn't you do that? Oh, I don't know why I didn't do why I did that way. Let's just do this. Integral of square root of 2 minus x squared times x minus x squared, and go from 0 to 1. Why are you not giving me the answer? Oh, because what's it? I don't know. Yeah, I don't know why it's not doing it. Let's just do it here. Integral. I just want the value. I just want a value of x times the square root of 2 minus x squared minus x from 0 to 1. That's all I wanted. What are you telling me? An illegal argument? Where?
Can you give us a list of what will be on the quiz on Tuesday?
Yes, I can. What? Oh, for heaven's sake, why are you being a pain? X square root of 2 minus x squared minus x squared. Okay. If I evaluate that from 0 to 1, if I put in 1, I get 3 halves. Oh, that's why it's coming out negative. So I think I get 3 pi. Something along that. That's not right. Oh well, anyway, I can't get the GeoGebra to do the integral for me. I don't feel like doing it by hand. So I don't know why it's not giving. I don't know why it's not doing the answer that I want it to do. Why are you not doing what I want you to do? Anyway,
Dr. Joe?
Yeah.
So for the first one that we did, we should have 2.6 something, and the other one we should have 9.6 something.
Yeah, 9.6, yeah, 2.6 something and 9.6 something. Yep. So on your quiz on Tuesday, least squares problem, Fourier series problem, Monte Carlo integration problem. 3 problems.
Will the Fourier series just be finding the Fourier series, or is it going to be like the...
Just finding.
Okay.
So up to how high are do we need for Monte Carlo?
Just like 5,000. I'll tell you how many.
No, I mean, do we need to know for the single triple?
No, just single. Yeah, just single integration. That's all you need to know.
And then for least squares, are there any surprises for that?
No.
It's a Dr. Joe test.
Oh, that one's on.
No, this is just a quiz. This is just quiz. It's just quiz. No surprises.
Thank you.
Yeah, you're welcome. Just want to make sure that you know the technique. So least squares, Fourier series, Monte Carlo. So least squares, like one of the 2 problems that you had in the homework over that. Fourier series, like the first problem, not like the second. Just the first problem, just get it in GeoGebra and get it pictured.
Okay.
Okay.
Yep.
So we don't actually write anything down on it.
For the GeoGebra parts, no. Let's give this email.
But there's going to be non-GeoGebra parts.
Yeah, Excel for this, right?
Well, the Excel, I guess you could just don't email me the Excel sheet too.
Okay.
So it's just
Or
gonna be
your Python code.
So it's just going to be GeoGebra and Excel problems?
That's it. It's going to be in class. Yeah.
Are you giving us the random numbers?
Yeah, you have your computer, so you don't have it, you don't download it.
Okay.
So we can use like our file.
Yep. Yeah, I'm not going to go look around everybody's computer and see if you don't have your Excel file. Please do. I will make sure you can do it. Literally, just quiz, can you do it?
Can we use our notes? Like
No,
on the equation.
But if we
I'll
have-
draw the line there.
But if we have the equations like in a
No idea.
Then, yep, it's already in the
So like,
GeoGebra
yes,
file.
we can, but
So,
no, we
yeah.
Yeah, no, you can't have anything written down.
We can use our electronic. It's like the
You can
previous
have your
examples that we've
computer.
done.
No, I understand that. It's just now I have to switch between GeoGebra files. I'm like, well, that sucks.
Yeah, you can't have more than one open at once. It's dumb.
I'm sorry.
That's just really unfortunate.
Actually, I don't think that's true. I think if you open it and then go back over to this desktop and reopen it again, I think it'll happen.
You can do it on the desktop.
Thanks for the pizza, Dr. Joe.
You're welcome.
For this stuff we just turned in.
Yeah.
So I was thinking like, for like the first one, the 1A.
Mhm.
So is the actual series this part, or is it this part? Like this is,
For QA?
yeah,
It's that part.
that part?
Yeah, yep.
Okay, it's not this part.
No, because that's what this is what you use from GeoGebra to get that part.
Extra credit?
Okay, that's what I was just.
I'm at breaking on my credit.
Dr. Joe, can you tell me what I did? I just want to get it so I know that I can do it, but I can't do it because it's not. You know.
I think my laptop is on its last days. When I was taking my model on 3D printing, I was trying to like dimension things and it wouldn't let me type in numbers.
Yeah, I think I see.
Yeah, I think you move this over. I think. Or I think you add. I think it's a negative 4/5, so this should be a positive 4/3. So you get 32/15.
Oh. Okay.
I think that's what you did.
All right.
Thank you, Dr. Joe.
Oh, you're welcome. Like I said, you've all put up a lot this semester, so.
So do you.
Oops, I just got food all over the floor.
Okay, I have a
They're
question.
gonna love us.
Yeah, that's okay. It happens.
So
See ya.
I was double checking all my the one problems like, and this one, the way I had it come out before, I don't think it's right because
So did you, I think you got the same error that you had before. So this
Are
is
you
your
kidding me?
constant.
I did it
I'm
right
gonna
the whole
divide that
time
by
and I didn't
2
add something right?
for your period.
Oh,
And then I'm gonna dig,
I swear to God.
this is right, but this part needs to be 1/3 instead of 2/3. Because remember the constant you have to divide by the whole
I'm trying to
period.
decide what I should do right now.
The sum you divide by half the period.
okay.
I'm
So
going
I think
home
if you
to
go up
actually get
here-
a day off. I'm so excited. I never get days off.
Well, I'm
And-
like,
I have work
I'm
later.
done,
Saturday I don't, but I do.
I'm
Of course,
done
it sends all the way to the back.
But I have a
Maybe when I tried to fix it, I put the wrong number in because then it just got smaller. But maybe I put
Well, all this should do right now is shift
First, I'm
it
gonna
down.
stop by Einstein
There
to
you go.
grab a
okay.
Yep, that was the only thing that was off.
Thanks.
Yeah, that was it.
What did I did something else then. I was like, this is not right either. Okay. Perfect.
Okay.
Missing those two.
So all we have left for this class is the quiz on Tuesday and the final assignment due during